go really quickly and talk about interpreting exponential graphs. So let's go to the first example. A scientist is conducting an experiment with an antibiotic on a colony of bacteria. The antibiotic that he introduces kills 2% of the bacteria every hour, and the remaining bacteria remaining each hour can be represented by that equation. And so they give you the exponential equation, and we're just asking questions. First question is, how many bacteria will there be left in 8 hours? And so you got two choices here. Both of them involve your calculator. Your first choice is you can put that function... Oh, I think I have way too many zeros there. Yep. We can put that function 1,000,000 times 0.98 to the power of x into our calculator, and we can go to the table. So we can go to second graph and go look at our table, and we're looking at for when it equals 8 hours. And so that's where we want x to be 8. And so you go down here to where x equals 8, and you get 850,763. That's what the table tells me. And you can use your table, or you can just type it in on your calculator, and you can do 1,000,000 times 0.98 to the power of 8, because we are looking for the 8th day, so we want x to be 8. And it will tell you, and you see it's not exactly 850,763, but it is close. We're going to round it off. And so right here, the bacteria left in 8 hours we have is 850,763. Now the next question is the same. We want to know how much is left in 24 hours. So we go do the same thing. We go to our calculator, and you can go look at the table, or you can do the same thing that you did just a minute ago, except now we want x to be 24, because we're looking for the 24th hour. I'm just going to use the function and type it in, because I know I can round, and there should be 615,780 bacteria left in 24 hours. So after 24 hours, I've got 615,000. Apologize. Going to push all the wrong buttons. 780 left after 24 hours. Now the next question is asking, how long will it be before the scientist has half of the beginning amount of bacteria? So if I go back and look at the problem, I got to figure out how much did he start with. So does it tell me anywhere in the problem how much he started with? Hopefully you remember that this number right here, the a value in your function, represents the initial amount. So initially there were 1,000,000 bacteria that he started this study with. So I'm looking for the point where there are 500,000 left. So I need y to be 500,000. So this is where my calculator comes in really handy. I'm going to go to the table, and I'm looking for the point where y is equal to 500,000 or close to it. I need there to be half. So I'm going to scroll through my table. I'm going to do this slowly because earlier I discovered if I go too fast, my calculator freezes. So you might get there before I do. I hear you, Felix. You hear my cat. She's talking to us. She's letting me know that she needs me to go away so she can go back to sleep. So there we are, right here. At 34, I have 503,000 about bacteria left, but after 35 days, or 35 hours, I have 493. So then I have less. And so if you go and read the question one more time, it says, before the scientist will have half the beginning amount of bacteria. Well, at 34 days, it's not half. At 35 days, it's a little more than half, but we're going to go with 35 days because we want it to be less than half, otherwise, if the other one just doesn't make sense. It didn't say more than half. He wants to be exactly half, but we'll go ahead and go with 35 days. Round it off so that we can be the closest we can possibly get. So it takes 35 days for there to be half. I'm sorry, it's not days, it's hours. 35 hours before half of the bacteria is left. So let's do the next question. So in 1985, there were 285 cell phone subscribers in the small town of Centerville. That must be a very small town. The number of subscribers increased by 75% per year after 1985. course, I guess in 1985, cell phones were those great, big, gigantic, ugly things that you probably see in the movies and make fun of. Question A asks, what's the meaning of the y-intercept? Well, the first thing you need to do is decide what exactly is the y-intercept. If you look at the graph, it's not an exact number. You see that it is somewhere between 250 and 300, but hopefully you remember that the y-intercept represents the initial amount. And so in 1985, there were 285 cell phone subscribers. So the meaning of the y-intercept is the initial number of cell phone subscribers. That's the, it's the beginning amount. So in 1987, about how many cell phone subscribers were there in Centerville? And so this right here is the years after 1985. And 1987 is 2 years after. So we're looking right here where it's 2. And we're going to just go up to the function. It's about right here. I drew a very unstraight line. And if you look at the graph, I can see that it counts by 50s. And this one's easy to read. This says 700, 750, 800, 850. So there were about 850 cell phone subscribers in 1987. Now C asks for the range of this situation. Remember, range is your Y values. And if you look at, and we're just talking situation, okay? We're not talking about the whole overall function and what's going to happen if we looked at this entire graph. Just of this situation, we started with 285 cell phone subscribers, and it is increasing by 75% every single year, and it's just going to keep getting bigger and bigger. So the range of this situation is going to be all of the numbers greater than 285, because that's where we started, and it's going to continue to increase. We don't have an ending point because we don't know how big Centerville is going to get. We don't know how many people live there, anything like that. So we're just going to say it's everything greater than 285. It can also be equal to, because we did find out that it was exactly 285 at one point. So it's everything greater than or equal to 285. And so that's going to be the range of just this situation. Let's do one more. So each year, the local country club sponsors a tennis tournament. Tournament play starts with 128 participants. During each round, half of the players are eliminated. So the first question is, what's the y-intercept? You can look at the graph, or you can read the problem, and you know that the y-intercept's the initial number of people, and so in this case, it's 128. So my y-intercept is 128 because that's how many people we start with. So what is the meaning of the y-intercept? It's the number of original participants, or it's the number of participants they start with. However you want to say it, you want to say that it's the number of participants, that they began with. And then the next question is, how many participants were there after the first round? So you're going to go up here, x equals 1. You hit the graph about right here. And again, these numbers are really hard to read, but it goes by 2s. And as I'm looking at my graph, I have to take that back. It goes by 4s. There's 4, 8, 12, 16. And so this is 52. This is 56. And so this is 60. And so after the first round, there were only 60 participants left. And so each round, half of the players are eliminated. I guess that number is probably not 100% accurate, because half of 128 is really going to be 64. So we're going to, I guess my line didn't go up. There are 64 after the first round. I guess it hits it more like about right here than it does right here, based on the graph. But anyway, so there you go. There are 64. Now, after 5 rounds, we're going to use the graph. This one's a little easier. It's going to be easy for me not to screw up. Right here, after 5 rounds, there are 4 participants left. One thing you can equate this little exponential graph to is the March Madness NCAA basketball tournament. This is what happens. They start with 64 teams after everything is set and you've done all the playing games. They start with 64 teams, and each round half of the teams are eliminated. You start with 64, and then the next time they have a game, there are only 32 teams still playing, and then after that round there's only 16. It doesn't take long to get to the Sweet 16 because we eliminate half every time. That's an exponential function, that March Madness scenario with the NCAA basketball tournament. If we were to graph it, it would look very similar to this, except it would start at 64 instead of 128. But anyway, there is interpreting graphs. All you got to do, you just use the graph or use the function, answer the questions that go with it. And that's all there is to it.